It's time for our third and final session of the day. It's all about unmanned aerial vehicles and policing. Earlier this year, Interpol released a new document. It was called Framework for Responding to a Drone Incident for First Responders and Digital uh, Forensic Practitioners. Interpol said it hopes that this will serve as a reference tool for the many officers who still do not understand these technologies. Drones have become a permanent fixture in the current policing operating environment, said Interpol Secretary General Jurgen Stock, and one that can only grow in scale and impact in the future. So we wanted to touch on this from a Canadian perspective. I'm thrilled to have here to do that Andy Olson and Colin Giles, both of Element 3 Robotics, and both with years of experience in the RPAS, which is remotely piloted aircraft systems, emergency services industry. The two will lead you through an update on the latest in two new UAV technologies for law enforcement. They will also touch on standardized training in this department and integrating these kinds of skills into your environment. I think we can all agree this is some pretty cool police tech, so don't go anywhere. Now, a little bit more about our speakers. Colin, who is joining us by phone, has 21 years of law enforcement experience with a major police agency. Over the course of his career, his experience has included tactical operations, incident command, search and rescue, K9 operations, public safety, and emergency management. Colin has been involved in the RPAS industry since 2013 and played a significant role in the development of his and other agencies' RPAS programs, and that's on an international level. Andy has more than 30 years of service in emergency response and more than 10 years of experience as an RPAS operator in the emergency services. He was one of the first operators in North America to be federally licensed to operate RPAS systems in urban areas. Very cool. During that time, he conducted RPAS operations in many critical incidents, including homicides, large-scale fires, missing person searches, emergency management, and was one of the lead proponents for the development of standardized RPAS training and operations for law enforcement operations here in Canada. Andy, Colin, I'm honored you're joining us today. The screen is all yours.
Thank you, Renee, and good afternoon. Just had to say thank you very much for the previous presenters. There's really a lot of good information here for all serving officers, whether they be in police, fire, paramedicine. Lots of excellent information. Before I get into our presentation, as Renee said, we're going to cover a number of different topics. I just want to give you a bit of a background on our company, Element 3 Robotics, so you have an understanding of the rationale as to why we exist, essentially, and our thought process behind what we do. So, as operators with a number of years in the drone, or in Canada we call it RPAS, remotely piloted aircraft systems is the legal term, we noticed that obviously a lot of people that are in the emergency services space wanted to get involved in the industry. Unfortunately, the downfall was that there was a lot of people that got into the industry somewhat early and were able to train operators that were new to the business. But unfortunately, none of those, or very few at least, of those trainers had any exposure to emergency services. So that created a huge gap in what we believe was the actual the learning ability and the ability for people that are coming to these training sessions to resonate with what they're being taught. In our company, myself and Andy and our other two partners are all active police officers. Sorry, Andy's recently retired, but we have a lot of experience in everything from the explosives disposal unit, collision reconstruction, forensics, search and rescue, and a tactical background. So again, that really drives home the fact that we can, when we develop our training, it's designed specifically for emergency responders, specifically in instance or scenarios that we've either experienced ourselves or can definitely relate to. Andy will show you later on the teaching principles that we use. And the reason we chose these principles, and again, he'll explain this, is because they're all scientifically proven, they're measurable, and they're very easily replicated. All too often we go to training and we find that, from year to year or even from month to month, we do something that we just don't do often enough to develop a fine motor, muscle memory, or develop the skill to the level where we think we're experts, essentially, or as good as we possibly can be. And you'll see later on how we're able to measure this training from operator to operator and even from machine to machine. So that's essentially why we do what we do, just specifically to cater to the first responder world and make sure that we're all going out there being as safe as we possibly can, moving the industry forward safely, and having a positive experience, getting into the RPAS space. So with that, I'll pass it over to my partner, Andy Olson.
Just looking back, so 2008, it was actually a Blue Line magazine that caught my attention. The unit I was in, we made use of military and police helicopters on occasion. And as you know, they're a great tool, but they can be very expensive and not always available. So it was actually Mark Sharp from the OPP up in Kenora. He he's retired now, private pilot, and also was a remote control hobbyist. And he made the pitch to Transport Canada to license what became the first federally approved, now it would be called an RPAS unit in North America. He was a big supporter of ours. He answered numerous emails and phone calls from me because there wasn't anybody to turn to back then. So the development of drones and RPAS systems around the world, I think kind of goes back to the work he did. And I also want to thank Blue Line for starting that off. So from that, there were literally only a couple of systems in the world. Today, I don't think anybody has a firm count, but there are somewhere in the neighborhood of 250 to 300 manufacturers of drones. Probably the most recognized ones take up the top 4 or 5 spots, DJI, which we'll talk about, and they go everything from a couple hundred grams in weight up to 15, 20, 40, 50 kilograms with all sorts of capabilities. And we'll talk about some of the most prominent ones for that. So Colin's going to talk a little bit about some of the Transport Canada regulations.
Thanks, Andy. Yeah, before we get into the the fun stuff, the equipment, and getting into the fun things we can do with that, I think it's very important for people to understand that Transport Canada plays a big role in what we can do, obviously in Canada. Lots of times people think, well, I can go get this toy for my kids. I go to Canadian Tire and buy them a drone and they can fly in the backyard. Unfortunately, probably back in 2016, 2015, that was the norm. It was pretty much the Wild West out there. Since then, Transport Canada has done a lot of work, a heck of a lot of work actually, to get themselves caught up from the regular traditional aircraft world to bring their minds down to these small little machines that can definitely impact obviously a person if they happen to come in contact with somebody, and also a traditional aircraft should you happen to have a collision with an aircraft. So over the last few years, they've been developing a regulatory structure, which is still again in development, but they now there is a set of rules that people have to abide by when they go and get a drone from Canadian Tire, from Best Buy, or whichever. So just so people are aware, anything over 250 grams in Canada is a regulated piece of equipment. So you can have either one of 2 licenses from Transport Canada, a basic or an advanced operator certificate, and that gives you certain capabilities in in different kinds of airspace you can go and fly your drone. The other important thing to note is that Transport Canada really recognizes the fact that first responders have a need. Probably, I guess it's very easy to separate that need from your commercial operator from your consumer operator, and they really recognize that from the very beginning. So they've been working directly with some first responder agencies just to determine exactly what those capabilities are and give us the the ability to basically get to a scene, not have to make a bunch of notifications, do a quick site assessment, and launch our equipment. So we have to give them a lot of credit for the work that they've done over the last number of years. The other organization we really have to talk about again is NAV Canada. So when you talk about airspace in Canada, Transport Canada develops all the regulations, and they design those regulations around safe air travel for passenger airplanes, essentially. The second agency that comes into play is NAV Canada out of Ottawa, and they essentially manage the airspace. So lots of times, again, for the general consumer, if you want to go fly a drone in a controlled airspace, whether it be a homicide or a search and rescue, if you're not a police officer or you're not a first responder, you have to wait anywhere from 8 hours to about 4 days to get permission through NAV Canada. So we're working with NAV to essentially allow first responders to check a couple of quick boxes, make a phone call to the tower, and launch their equipment. Next slide, Amy. This slide is just basically to give you a general idea as to why there's regulations that are surrounding these machines. Obviously, the numbers in the U.S., you may or may not have heard, are substantially higher. As you can see, 2020. That number I got from Transport Canada back in February, so it's significantly out of date. But there are a lot of people out there that either don't know the regulations or don't understand why there are regulations. And the rationale is basically this. There's been lots and lots of testing for traditional aircraft, windshields, airframes against biological type of, like against birds essentially. So the challenge that we face now with drones is that because the drones are a hard, rigid material, they don't react to airframes and windshields the same way as a bird strike would. Where a bird strike would essentially disintegrate on impact, in most cases, the drones actually penetrate the airframe, which is why there's such a concern. So now to the fun stuff. Just to be clear, our company is not a vendor. We're not recommending any equipment. We don't sell anything here. We're specifically into training. But we're lucky in the fact that because we're so embedded in the industry and we're embedded obviously within first responders, we come across equipment that we think is probably more ideally suited to what we do as first responders as opposed to the hundreds of other pieces of equipment or hundreds of other manufacturers that are out there. So this is a piece of equipment that is made by DJI, which is the largest manufacturer of drones in the world. And this came onto the market late 2019 last year. So in general, when first responders had bought drones, we'd had this really cool piece of equipment, had a camera on it. We're able to take it off, go take our pictures, come back and or maybe even stream that video if we were lucky. Generally, they were larger pieces of equipment where it could be difficult to fly close range to a building. If you're doing a hostage call and you want to peek into a window, for example, or go down, fly through some trees because you're doing a search and rescue call and you need to get low to the ground. We didn't really have that capability before. So in 2019, DJI released this Mavic Enterprise Dual. And this really was a game changer for first responders. If you can see from the pictures there, on the left-hand side, there's a beacon on top. What that allows us to do is basically to fly at night. So if you have those capabilities through your relationship with Transport Canada, and you have some kind of tactical call, you need to fly at night, you now have a beacon that other aircraft that are flying in the area will be able to notice your UAV if you're flying at altitudes where low-flying aircraft might be. For example, you have somebody coming into a landing at the end of a runway. Now they're aware that your drone is flying below them. The second picture in the center is actually a small speaker. This was again a game changer for us. There was previously no way for either the drone operator or command to communicate with a lost person, for example, or to remotely give instructions to, again, a tactical scenario, you want to call somebody out of a house. We only had the ability to take pictures or to stream images before. Now with the speaker, you can actually broadcast, it's not real time, so you can't hear, but you can broadcast either a looped signal or record a signal to your device and essentially send it off to the drone within a number of seconds. So you can have almost real-time communication with the last piece of equipment that this machine brings to us is a floodlight. Again, it's an essential piece of kit that we never had access to before. Being able to light up a scene at night, augment our search and rescue capabilities if you didn't have a thermal imager on board. It opens up endless possibilities. The biggest change that came when this piece of equipment was released is the fact that it came out with an onboard thermal imaging camera. Generally, the larger drones had thermal imaging cameras that had been pared down from military-grade machines. They weren't very good at all. They were very pixely, hard to read, tough to really delineate, between a person or a rock, for example. So the thermal camera on this machine really changed the game there. So this again is a better image of the floodlight that comes along with this machine. In testing, we've used this to, again, at nighttime, look in windows. This scene is obviously lighting up a downed victim, search and rescue victim, and again, really opens up our possibilities. The nice thing about these machines as well, as technology changes, of course, things get cheaper. So as Andy said, 5 years ago when we're buying these machines, there's only a few around. We're paying $67,000 to $80,000 for a drone to get into the industry. Now we're paying $5,000 or $6,000 for technology that's far more advanced. Get another shot of the speaker. So this is the what we had in 2016 for thermal imaging. Again, it's useful. You know, you can see what appears to be some black shapes toward the top center of the screen. Obviously, if you're involved in that incident, you probably know what those are. But other than that, if you just looked at that picture, you may not know, other than buildings in a silo, what that actual image was of. So DJI came along with this machine, Mavic Enterprise Dual, and a couple of the other models, and they developed something called MSX technology. And I understand that generally in law enforcement, we deal with the black hot and white hot template for thermal imaging. This one just is a different color palette. But what you can see on the top two pictures on the right-hand side is a picture of a train, which is your general image for thermal image you would get. What they've done is with this MSX, they've taken the visual camera and the thermal camera, and you can overlay them with an edge detection algorithm, and it allows you to actually, as you can see that the boxes of the train, or the bottom picture, you can read the words on a sign. So put that into a hazmat scenario, or some lots of other scenarios where you can't delineate a person versus a rock. Now you're able to actually pick out the different lines of the body essentially, and just put you much further ahead in what you're doing for your mission.
Okay, thanks, Colin. So I was just going to talk about another DJI product. Like we said, we're not, DJI is the dominant player in the market. They've just come out with this system, which we've tried, and we're very impressed because it kind of raises the bar again. Not going to go through all the stats, but some of the interesting one is, even up until recently, flight times were in the 15, 20, 25 minute. They're now quickly approaching an hour, which changes a lot. The other two interesting things on here are 7,000 meter service ceiling and 15-kilometer range. Right now, most Transport Canada regulations require you to be around 120 meters in height, unless you have special permission, and line of sight, which in most cases is a few hundred meters, maybe 500 meters. This is 15 kilometers. So you can see the technology is pushing the envelope. And that is always going to be a challenge. The consumer demand and commercial demand for these systems has so many different applications that the technology literally moves so fast. As a bomb tech operator, the bomb robots I used 10 years ago have only made incremental changes, whereas with these, like a brand new system I bought a year ago is totally changed now within the space of a few months. So the technology is moving much faster than the regulations are able to keep up, and that makes for a big challenge. One of the big advantages that this system brought was before, there have been zoom cameras for a while, there have been thermal cameras for a while, but usually it was a case of, if you knew what you needed, you would fly with a zoom camera. If you thought you needed a thermal camera, you'd put the thermal camera on. But now what DJI has done is be able to bring all that technology into one camera, which has kind of changed everything. So on this example, you see at the top, there's a 12 megapixel wide view camera, 23-time optical zoom, which combined with the digital zoom gives you a magnification of close to 200, and then the high-end 640 by 512 thermal. So what that lets you do is, in this case, the picture on the left would be the wide angle view, which will give you a good situational awareness overview, a quick push of the button, and you're on the zoom. The other advantage these systems have now is target tracking. Push of the button, and you indicate the target you want to follow, and it'll follow that target. That technology's been around for a few years, but it wasn't always that good. Like a lot of things, the systems learn, the demand is there, and these systems are really good. We did some tests where I went behind a building and the camera would follow me. Older systems, it would lose you. Now it's almost like it waits and anticipates that I'm going to come out on the other side, and it'll pick up that target again. So much improved. Other things it has are the laser rangefinder. You can see here from the system to the target is 402 meters, and it'll also give you a lat and long position. Having the 3 payloads in one camera provides other benefits. In this case, you see on the far left is the wide angle view, the far right, exact same position, but with zoomed in, and then you get the high resolution thermal imaging. This is a radiometric thermal camera, so that means each pixel, and there's thousands of them, each pixel has a temperature setting which lets you do a lot of post analysis. Another change, it's not unusual for systems to be able to carry more than one camera now. What this system does was to be able to let you the option of carrying one camera, which from the camera we just saw is actually 3 cameras in one. You can carry a top and a bottom camera depending on what your purpose is, or you can carry 3 payloads. In this case, there's 2 cameras and a spotlight. It has the capability to carry loudspeakers. There's chemical detection equipment. Basically, if you can imagine it, somebody's developed a payload for it. This is basically the drive view of it. One of the big changes in it is all the information that's now much more easily available to the operator. So you can see the speed is there. In this case, it's meters per second. It could be miles per hour. Basically, you set it. The altitude. The screen at the bottom will actually, there's 360 degrees, almost 360 degrees of sensors. So you'll see as you're approaching the pillars, normally you would not drive a $50,000 machine through those because you're going to be out of a job by the time you're done. But with this, you can see at the bottom where the yellow indicators are in the bottom. So those are the proximity sensors. So it'll tell you as you're getting close to a wall or a tree or a target. And the system is actually sensitive enough that if you drove it towards a wall, it would brake and stop the operator, stop the machine from crashing. It'll actually pick up things like telephone poles or trees if the tree is thick enough and stop the machine from crashing. So it provides a lot of inherent safety for the operators. One of the other technologies that has come along too is sort of a blending. A lot of command posts have telescoping masts. They only go up 20, 30, 40, maybe 50 feet, something like that, which doesn't really let you see over a 2-story house. So this is an example of a combination of blending of technology. This one, you don't need an operator's license. It's basically a deployable drone on a tether. This tether goes up 150 feet. It just stays in one place. The 55-minute flight time for the 300, in this case, it's unlimited. You could stay up for hours, probably days, and leave it unattended, or you don't have to watch it constantly. You're not operating it, so there is no requirement to be licensed. So that's an example of some of the technology that's coming along. Just another example of the tethered system. It's portable. You can carry it in a rolling case or mount it on a vehicle. In this case, it's mounted on the top of, in this case, it's a fire truck. It could be a command post. That gives you an idea of how this technology is progressing. So we're going to, just watching our time here, we're going to talk about standardized training. One of the big challenges of standardized training is to, number one, have a program that's recognized. In my sort of previous world, we started working with this group a few years ago on the bomb side, bomb robots. ASTM is a widely recognized global standard in a lot of things, not just robotics. It's a standard for a wide range. NIST is a division of the US Department of Commerce, and they're the group that we started working with, and they've developed a methodology that we're looking at to adopt in the robotic field. Basically, this one just acknowledges that, you know, when we talk about NIST, we're actually recognized as collaborators for the NIST program, both for the aerial, the drone portion, as well as the ground, the bomb robots, and the water unmanned robots as well. So the purpose of the project, ground, air, and water, is basically to develop a way to evaluate not just the systems themselves, because there's so many and different capabilities, but also to evaluate the pilots, the operators, and to be able to collect that information and use it effectively. These are the main approaches. One was to develop reproducible test methods. It's great to have a program and a $15 million facility, but if you don't have access to a $15 million facility, you're not going to be able to do the tests. So it has to be duplicatable. I use the example in policing of qualifying your pistol. It's basically a paper target that you shoot at. So it has to be something that's reproducible. You have to be able to measure capabilities. As we said, there's an enormous range of robots and capabilities out there. So you have to be able to know a department's not going to be able to buy one drone in this case that is going to do everything. It might be too small for certain applications. It might be too big. You can't take the M300 and fly through a house. It's just not going to work. So you have to understand what you're doing. Inspire innovation. If there's something you need and you need to be able to communicate it to a manufacturer or a representative, you can use these tests to kind of explain what it is you need. A guide to purchasing and deployment. There's lots of examples out there. I know in my department and others of equipment that was purchased and never used because it didn't ultimately fit the role that it was designed or purchased for. So to be able to make a purchase knowing on what you need it for. If you're shopping for a car and you need to carry a lot of stuff, you're probably not going to buy a four-door sedan. You want to buy something that's suitable, like a pickup truck or a van. So this gives the purchaser that sort of information. To focus the training, to be able to develop training that's specific to your task, and to identify readiness issues. The test methods cover a wide range of areas, everything from visual acuity, even if it's the same manufacturer, every camera will pick up colors differently. Thermal cameras will have different capabilities. You want to be able to know what those limits are. Endurance, how long a system, whether the battery lasts 15 minutes or 20 minutes or 25 minutes, those are all important things. The red box is basically what was identified as what the basic core skills should be. What an operator needs at a basic level to ensure they're competent, and that would be just the basic flight maneuvers, to be able to maneuver in a position and rotate the system, climbing and descending, flying straight and level, moving and rotating, and landing and taking off. Those are the core ones. This was designed for ground robots, this slide here, but it applies equally to the aerial one. So the top one would be a test that's applicable to a certain task. So you see, like, maybe the robot course here is sand or gravel ramps. Down below would be, you'd see robot A, robot B. So that would be a specific system and how it did on a specific standard test. So in this case, if you needed a ground robot that was really good in sand, you probably wouldn't go with robot A because it didn't do that well. At least it would give you that information. Whereas robot H on the far side did pretty well in sand. And those metrics and indicators are there for each test. And this applies equally for the aerial systems. All the aerial systems that are designed have certain applications, and it allows the operator or the purchaser to make an informed decision. The tests have to be easy. This is the basic test. You can see all the fabrication guides come there. These are provided by NIST. I'm not a very handy guy. My handyman skills are limited to hammers and screwdrivers, but even I can build these. If you go to a local hardware store, it's about $200 of wood. You need, like, obviously some kind of a saw to cut it, a few little pails, the stickers they provide. This third picture here is basically the entire course stacked up. So space, cost, and build construction are not really big issues. So the stickers, there's two basic functions of the stickers. Down at the bottom, they're put in buckets so that the operator has to be in a certain position. If you're too far left or right or up and down, you're not going to see the target. So it kind of focuses on the task at hand. In this case, the operator would fly the drone over a bucket, and their purpose would be to see that green circle. If they see an entire green circle, they're in the right position. If they don't, then they're not, and they wouldn't get the point in that case, or the mark. On the right is the payload functionality. So that's designed to test the camera abilities. Some of the smaller systems have great cameras, but you need to know how close you're going to get. These are called the Landau, it's the concentric Cs, Landau test method. So what the operator would be looking for is where the gap in the C is. So on the large one, which most systems can see relatively easy, that gap would be on the left. The next one in would be bottom left, and then there's actually 5 circles in there. How this translates to the emergency services is, if you were a police operator and you're looking for a license plate, the second ring in there, if you can see that, then you can see a license plate, which on a lot of the smaller systems means you're probably about 10, 15 feet away. On the smaller system, if you're 30 feet away, you're probably not going to be able to read a license plate. So you know you got to get in closer. If you have a big zoom camera, you could probably be 400 or 500 meters away. Because you have the zoom, you can see the camera. So it gives you an idea of what the capabilities of your strengths and weaknesses of your system are. These were some tests we did at the Ontario Police College a year ago. So we ran those basic lanes, 5 of them, I think, and ran the operators through it. The examples in the back are the ground, the bomb robot test. That wasn't part of the aerials. But this gives you an idea of that's 5 lanes in a relatively small area. These same test methods, this was in Japan. So this is taking those same buckets, the same inserts, stickers, and applying them into some kind of a real world situation, something that a company or an agency might be required to do, and evaluating the operators and the system. This was again at the police college, a test we did. It says Canadian Police College, but it was actually Ontario. So this was a vehicle. If you're going to do a vehicle inspection, the buckets on the top would force the operator to do a 360 to get a full perspective on the vehicle. And then you put stickers around certain target areas, license plates, VIN numbers. On the right, you'll see the interior. So you want to be able to check out seats, footwells, steering columns, VIN numbers, anything like that. And then you can see some buckets on the underside of the vehicle. Scaling up again, this is a cube van, the exact same thing. You put stickers by where you want an operator to target, license plate, VIN numbers. In this case, there's a hazardous material sticker. Larger vehicles have a cargo area. If your system's small enough, you can fly in there and identify targets. Or if you have a zoom camera and a bigger system, you can probably still accomplish that. Scaling up again, this is in Colorado, same thing. Same stickers, same buckets, spread them around the vehicle or the area and do the same course. Same thing in a building. This could be exterior or interior. You take the same buckets, you put them around the areas that you want the operator to be able to target. You can challenge them. You can make some easy, some really challenging, and you can replace stickers with sort of target specific objects, hazardous material stickers, license plates, guns. You can name it. You can print off a circle and put it in for the operator to see. Any kind of standardized testing has to be varied enough to apply in different situations. These kind of test methods are primarily used in the daytime. For night operations, you can either illuminate the same targets by external lights. You can put headlights in them, or sorry, headlamps in them to light them up, or leave them dark. BV loss is beyond visual line of sight. Right now, everything has to be done. You have to be able to see the system. And you have to stay under 400 feet. If an emergency service operator flies behind a building that's just a few feet away and loses sight, technically that's against the rules. Transport Canada knows that's an issue. Those rules are probably going to change, but how do you evaluate the systems that can do that? How do you train the operators to be able to do that in a standardized fashion? And that's how we see this being a benefit. This is the score sheet. It looks complicated. It's actually a lot simpler than it actually looks. This would be the, I know we're kind of running out of time, so I'm going to go quick. So this would be whatever course you're going to do. It gives an idea of the circles and what the objectives are. The spacing can be changed. It could be a 10-foot spacing if it's a small system. Could be 20 feet, 30 feet if it's a larger system with a zoom. It gives the full instructions on what the operator is supposed to do. And those instructions are read out by somebody beside them. None of this is a secret. And then they're evaluated based on how they pick up those targets. There's no, the pass or fail is determined by the agency itself. If they determine that an operator should be able to do this in 5 minutes, then that's their pass or fail. Other agencies might say 7 minutes or 10 minutes. So it's totally up to the home agency. This is my last slide, and I'll turn it over to Colin again quick. So one of the benefits that we saw was to be able to compare operators and systems. This is actually, again, for the bomb robots, but what it shows is the different colors represent either police or military bomb operators and how they did on a specific course. You can see the little red maple leafs, so a lot of the Canadians did well. A military operator who operates a robot all the time should be pretty good. most of the police operators are part-time, they do other jobs, and then they do their bomb job, so they don't get as much time. So you'd think that without enough time, their scores would be a little bit less. The orange ones are a professional, probably a manufacturer's rep. So what this shows you is if your operator is down at the far right, maybe that operator is brand new, maybe they haven't flown in a while, or maybe they need some work to keep up to where the rest of the pack is. So there's a lot of valuable information in having standardized testing to be able to compare an operator in Ontario with an operator in Nova Scotia or an operator in British Columbia. And we see this as a way to do that. So I'm going to turn it over to Colin to talk about the new SARA Association.
Thanks, Andy. This will be our last slide, everybody, just so you know. Just briefly want to touch on this new Canadian First Responders Robotics Association. As I mentioned earlier in the presentation, one of the things we run into is a lack of standardization, and this is nationally. It's internationally, but we're gonna cover Canada. So we developed this new association that basically we're going to work in concert, or we are working in concert with the regulators and with a number of agencies in Canada to develop a standard. So based on these NIST standards that Andy just talked about, we'll have recommendations come out from the association for people that are operating in the drone space. So that we're all on the same page essentially, and obviously there'll be certain benefits for operators once when they get the training, they get to speed in their training, they'll realize with us operating in concert, we're all moving the industry further together, as opposed to all doing a number of different siloed attempts at developing our drone program. So I want to thank everybody for their time and their patience. That's all we have for today. I'll turn it back over to Renee.
Wonderful. Thank you guys so much. Wow. I mean, even just from last summer's event that I attended, that you guys hosted at Mohawk College, there's been some changes. So I certainly learned something new. A crazy comparison between the bomb robots and the UAVs and how quickly that technology is evolving there. So thank you both, Colin and Andy, for sharing that. We have some questions from the audience. So the first one that has come in is here. In Europe, local police forces are successfully using UAV scramblers to enforce drone regulations, e.g. to secure airspace during major protests. So will community police agencies across Canada be allowed soon to use such tools? Do you have any insight there?
So the use of jammers is heavily regulated in Canada. Detecting drones is one thing, but even if you detect it, there's a big question about what you do. If you were to bring it down and it crashes, that could be a bigger issue than the drone being where it's not supposed to in the first place. So the short answer is, as far as jamming, there are technologies out there. I don't know that police agencies are going to be using that anytime soon. I think it's going to be more a question of the regulation, being able to detect the systems, and then being able to send ground units in to try and locate an operator, rather than actually taking control of a drone itself.
Wonderful. Thank you, Andy, for that. All right, another question here, kind of a fun one. Are you guys willing to share your favorite drones personally that you use?
I don't have a lot of the fun equipment that some larger agencies have. The one I really enjoyed was the one that I outlined in the presentation, is the Mavic Enterprise Dual. Just because of the capabilities, and if you're doing training, being able to yell at your buddies or give them direction through that speaker, and again, the fact that it has that thermal and the spotlight really opens up so many doors. It's the one that I like to operate the most.
Wonderful. Thank you, Colin. All right. Okay, well, that's it for those questions coming in from the audience right now. Thank you again, both Andy and Colin. I appreciate you guys being here. You're closing our knowledge gap a little bit more when it comes to those UAV updates for 2020. There's always something new, so I appreciate it. Congrats on the new association, by the way. Do keep me posted, and we'll be sure to follow along that journey there. Thank you to you both.
Thanks, Renee.
Thanks, Renee.